All right, so again, P4 is graphs of equations. It starts by identifying a point on a graph. So if a point is on the graph, then when the point's plugged in, the result will be a balanced equation. So I would say this is helpful, like obviously even on standardized tests, you might get some really funky equation, and then it could ask you if it's a solution to the equation or a point on its graph, and all you have to do is plug it in. So an example would look like this. Determine if 1, 5 is the solution to y equals 4 minus that's absolute value of x minus 2. So I take the 1, that's my x, I take the 5, that's my y, and I plug it in. 5 equals 1 minus absolute value of 1 minus 2. Is it not a what? 4. This is a 4. Yes, sorry. And then do what's inside the absolute value first. So 5 would equal 4 minus the absolute value of 1 minus 2 is negative 1. 5 equals 4 minus a positive 1, and 5 does not equal 3. So this is a no. That would not be a point on the actual graph of this function. So obviously that's easier than trying to go through and take your absolute value, shift it. This would be a shift to the right 2, upside down, and up 4, and then try to plot a point. It's way easier, just plug it in. All right, then comes intercepts, and we've done this a bunch throughout the school year. So to figure out what the x-intercept is, we're going to plug 0 in for y. To figure out the y-intercept, we're plugging 0 in for x. You can also read it from a graph. So example 2 says find the intercepts from the graph, and then algebraically. So from the graph, obviously, we're looking at this graph where it crosses the x-axis. This would be 2 and negative 2, so x-intercepts are negative 2, 0, and 2, 0. And then the y-intercept is here. This is not going by 1, so it's going by 4. So if this is 4, this is 8, this is 12, this would be 16. So the y-intercept would be 0, 16. So that would be graphically. Then algebraically is we plug in. So to find, the x-intercepts, we plug the 0 in for y. So 0 equals 16 minus 4x squared. And then a couple ways to do it. One would be move the 4x to the other side, divide both sides by 4, square root doing plus and minus. So that would look like this. 4x squared would equal 16, divide by 4. X squared would equal 4, square root both sides. And you'd get plus and minus 2. So there's your negative 2, 0 and positive 2, 0. Or this is the difference of two squares, so you could also factor it. This would be 4 plus 2x, 4 minus 2x, and then you can split and solve that. 2x would equal negative 4, x would equal negative 2, 4 would equal 2x, and x would equal positive 2. You could also have factored out a 4, and it would have been 4 minus x squared, and then you could have solved and factored and solved that way. So a couple different ways to do it, but all three ways give you the same x-intercept as what we got from the graph. For y-intercept, we plug 0 in for the x. So I get y equals 16 minus 4 times 0 squared. Square the 0, it's 0. Multiply times 4, it's 4. And y equals 16 is your y-intercept, which again matches your graph. So if you had the graph, you could use the graph. If you don't have the graph, obviously, then you want to do it algebraically by plugging in your zeros. Still good? Yes. Still stuff we remember, right? Okay. And then the last thing is symmetry. So to test for symmetry from a rectangular equation, which is what we're back to, the test for the x-axis symmetry is plug negative y in for y. The test for the y-axis symmetry is negative x in for x. And the origin is both negative x and negative y. Once you plug those in and simplify, you're looking for two things to happen. One is that the equation goes back to the original form, so all of the signs would go back to positive. Or each term is the exact opposite on both sides of your equal sign. So every single term would have to change sign. If either of those two things happen, then it passes the symmetry test that you just did. So if it happens when I plug in a negative y, then it's symmetric to the x-axis. If it happens when I plug in a negative x, then it's symmetric to the y-axis. If it happens for both, then it's symmetric to the origin. So something can just, first of all, something can be none. Something can be just x, something can be just y, something can be just origin. If it's x and y, it is automatically origin. That's the only thing that would be automatic. But it can be origin and not x and y. So be careful there. The other thing you could do is test it from a graph. So if my graph is symmetric to the x-axis, so if I fold it along the x-axis, like absolute value maybe turned on the right, this would be symmetric to the x-axis. If it's symmetric to the y-axis, then I would be able to fold it along the y-axis, so maybe an absolute value that's pointing up. And then if it's symmetric to the origin, what happens in the top right quadrant happens in the bottom left. So a cube root function would have symmetry to the origin, okay? Just a y equals x line would have symmetry to the origin, or y equals negative x would have symmetry to the origin. So whatever's happening in the top right is happening in the bottom left, and vice versa, top left to bottom right. All right, last set of examples. Find, so this should say find or test for symmetry. So for A, my x-axis symmetry, then my y-axis, then my origin. So for the x-axis symmetry, we're going to plug in for y, x minus. When we plug it in inside the parentheses. What happens when we square the negative y? Goes back to y. So this would be x minus y squared equals 0. Then we're comparing it with the original. It is equal to the original, so it passes the x-axis symmetry test. So this has symmetry to the x-axis. Then we would do y-axis, so I plug in a negative x. Nothing gets simplified. It is not matching the original. One of the signs is opposite, but not the other, so this would not pass the y-axis symmetry. And then origin, you're going to do both. Negative x minus a negative y squared equals 0. The negative y squared goes back to positive y. So that sign matches. The x changed, however, so this would also fail the origin test. If you think about it, what is this graph? It's a parabola, so this would be x equals y squared. So this is a parabola, but what way is it facing? The right, because it's a y squared. It's a positive, right, y squared. So that makes sense that it would be symmetric to the x-axis, but not the y or the origin. All right, you go to B. So x-axis test is first plug in a negative y. Nothing changes. It does not equal the original, so this would not be symmetric to the x-axis. Y-axis, I plug in a negative x. Negative x to the fourth minus negative x to the second plus 3. And every time I raise that negative x to an even power, it's going to make it go back positive. So this time it equals the original. This would have y-axis symmetry. And then origin, the y changes. And the x changes. We know the x's are going to go back to the original, but the y changes. So this would fail your origin test as well. This is only symmetric to your y-axis. This is a parabola shape because it's got the x to the fourth, but it pointing up, so it should make sense that this would also be symmetric just to y. That's it. Questions? Easy stuff, right?